Welcome to the tutorial for SHINING3D Inspect. Recently, we added some help functions into the software, providing more methods for alignment and offering more functions on computer part. Let's dive into it. For the alignment, now providing 3-to-1 alignment aligned to the coordinate system and RPS alignment. 3-to-1 alignment involves aligning the model by determining 6 degrees of freedom, primarily used for measuring gauge models. And before starting alignment, you need to create one point, one line, and one plane. The point could be center of a circle or sphere, and the line could be corresponding axis of the cylinder or cone. Choose 3-to-1 alignment and select measure data and to be aligned and the feature sequence. And select the features one by one. Click Preview to see the alignment result in 3D scene and click Confirm to save the alignments, which will be displayed in the aligned group corresponding to the measure model in the left side tree view. Align to coordinate system enables to align an existing measure data to a desired coordinate system by using 3-to-1 method or vertical planes. This function facilitates better observation and measurement of the model, especially when you only need to do inspection on scanner. RPS alignment is mainly applied in sceneries such as workpiece alignment, assembly parts, quality control, and mode point measurement. By using RPS alignment, the specific points, circle, and sphere features can be matched to align the models. Click RPS alignment to open the corresponding window. Select the measure data to be aligned, and click in the 3D scene to select at least 3 feature pairs or labels. And the selected features will be shown in the Select Feature Targets column. Select the alignment direction in RPS alignment window and edit parameters. Then click Preview to see the alignment result in the 3D scene, and click Confirm to save the alignment project. In the computer part, now we're providing 3D local compare for partial comparison, cross-section for 2D compare, and the comparison point to check the deviation for specific points. For 3D local comparison, select the reference data, the measured data to be aligned and an aligned object, and click the model to select one or multiple surfaces. You can use Delete to cancel the selections. Add parameters and choose your template. Click Preview to display the 3D color map of the selected surfaces in the scene and the ribbon in the right. In the preview state, you can click on the 3D color map of the selected planes in the scene to create comparison point, or right-click on the 3D compare project in the tree view. Click Edit Comparison Point and click on the 3D color map to create. And you can also click the Comparison Points function to create points. After getting enough points, click Confirm to save the 3D compare object. For 2D compare, you need to create a cross-section first. There are 2 ways to create cross-section, from planes and along specific directions. Take from planes, for example. Select a created plane, set the offset distance, and define a cross-section as reference or measured. Then press Confirm to create a cross-section. Select the cross-section pair to be compared, and don't forget to extract measured cross-section. Edit parameters, choose a ribbon or template, and customize display settings, including whisker multiplier and whisker display ratio. Click Preview to display the 2D cross-section color map in the scene and the ribbon in the right. And the same as 3D compare, you can create comparison point by clicking on the 2D cross-section color map. Then click Confirm to save the 3D compare object. That's all for this tutorial, and feel free to contact us if you have any problem on using SHINING3D Inspect. Thanks for watching.